Hi folks, I'm Anirudh Aris, and I'm here to present you my project on managing machine learning projects course offered by the Duke University through Coursera. So let us get started. Topic overview. So we will be covering five subtopics. First one is opportunity evaluation, CRIPS DBM business understanding, solution validation plan, ML system design, and potential risk that can occur in the production. So opportunity evaluation. So our problem statement is to predict the time required to complete software development tasks to support more accurate sprint planning and team capacity forecasting. So is this a problem? Yes. So the task time estimates in software development are often very inaccurate due to reliance on intuition or past experience of the manager or person creating the task. So this leads to overcommitted sprints, poor capacity utilization, and burnout from very unrealistic expectations. So can ML help you? Yes, it can. So ML can analyze historical data such as task description and a lot of other metadata and similar past commits, and then it can predict the task duration. It can also take into account the overheads that happen during the build time, production, testing, and then finally getting it through the production. So it can take in a plethora of features and then give us unpredicted output. So does someone care? Yes, a lot of them care. Software developers, scrum masters, project managers, and all through the engineering leadership, product managers, everyone cares code estimated time of completion, which enhances confidence in the delivery timelines uh, for the clients. So we have three subsections that we will be covering as a part of Christian business understanding. One is problem analysis, second is success metrics, and the third one is factors involved in this whole model creation. Let's get started with this. The problem statement is that currently accurately estimating the time to complete software development tasks is challenging, and the manual estimates are often inconsistent and very subjective, leading to planning issues, inefficient resource use, and then there's a lot of missed deadlines. The gaps in the current solutions is we involve gut instinct a lot and then ignore historical pattern, code complexity, and team dynamics. Existing tools lack intelligent data-driven predictions that adapt to team context and task specificity. So our target users are Scrum Masters, project managers, developers, and engineering leads. Why it matters? It matters because improved estimates help avoid developer burnout, prevent overcommitment, and enable more realistic sprint planning, and that increases the team morale and the satisfaction of the delivery timelines. The expected business impact is by providing accurate task duration predictions, we would be able to improve the workload distribution and the management health of the employees. And over time, it helps engineering teams improve velocity tracking and reduce planning uncertainty and build trust in estimates. The output metrics, which points to the factors that would have an impact on the model efficiency, that we would track our mean absolute error and mean squared error of predictor versus actual completion time, and the accuracy compared to baseline methods such as average pass time, a plethora of other overheads, and the percentage of tasks falling within acceptable prediction error ranges. This is very important because we can't achieve 100% estimation accuracy. So we might have an acceptable threshold through to which we are all fine with uh, accepting the deviation from what realistically has happened. So the constraints we have are inconsistent historical data, evolving code base, new technology often reduces time of completion, and unquantified task complexity. Sometimes the task complexity is not defined by the lines of code, and not much depends on the historical context, but new context does change the status quo. And external dependencies impacting the task duration and quality and speed of execution. So these are other external factors that we might put a constraint on our model development. So the factors involved. So we have two main factors. One is output influencing factors. The other one is outcome. So the output influencing factors include accuracy of historical completion time, quality of description of task detail, and story points, priority labels, type, whether it's a bug or a feature request, and developer or team history with similar tasks, code complexity indicators such as file size, commit size, and the build and deployment overhead through the CDK pipeline. What does it mean is through the phase from testing to deploying in the production for customers' use, and handling of missing and outliers, and frequency and distribution of delayed versus quick task. So these things would affect our model creation and the business impact creation. Uh, that could be influenced by the outcome influencing factors. First one is team trust and willingness to adapt our MO-based estimates, integration of model predictions into sprint planning workflows, interpretability of predictions very important, and use of predictions to guide planning decisions. And it's not just as a reference, but to actually believe in the estimate that's being given by the model. And impact of external blockers or cross-team dependencies could be a major factor, and measurable changes in sprint success rate and the team morale. So these are some of the factors that affect the business adoption of our model. Solution validation plan. So how are we going to validate the solution? Well, the first thing is we divide the data into training, validation, test set, and then evaluate on the output metrics, and then we do a k-fold cross-validation on performance. So once we have a good model that's been built and thoroughly validated, we go through the iterative five-step process to understand and better serve as a framework for agile methodology. First one would be to create a mock-up design of how it might look, and then ask for peer feedback. And once that is done, we create a model based on a very small subset of historical data, and then take feedback based on that usage by our internal consumers. And the third iteration would involve heuristic real data training. So we use real data, but we would use a very simplified heuristic based predictions based on much lesser features, and you see the uh, impact of that estimates in their sprint planning, and we'll be able to monitor and track it. Then we'll create a very simple ML model in iteration 5, 4, and in iteration 5, we'll create a complicated model with complete iterative retrains, flywheel cycle. And our deployment will follow the A or B phase out strategy, and then validation of metrics that are set to monitor the production employees or the customers. And partial scaling, beta analysis, and continuous monitoring for any data drift or the concept drift is quite important, which we'll cover much later. So how are we going to design this model? We have a few questions and few choices to make here. So is it going to be a cloud model or edge model? So the questions we ask ourselves is, internet connectivity is needed? Yes. We can assume that good internet connectivity in our organizational framework is expected. Is privacy a concern? Moderately, because we would sort of have an organizational privacy framework rather than a sub-team privacy level focus. Is latency a concern? Yes, it is a concern, but it can be moderate. So it is not as deep as a face recognition tool that happens in an iPhone, or little latency is very acceptable. And can hybrid model approach resolve any limitation? Yes. So sensitive data for critical teams that handle the red data can utilize smaller edge models deployed on their cloud infrastructure specified for their team. So are we going to go with offline or online learning? So do we need a schedule or real-time model learning? So we might need just a schedule, a retraining, because uh, it might not need a real-time retraining. It might need a batch-wise retraining. Is continual retraining required? Yes. As the code base as it were, we might need continual retraining. It's not a one fixed model. Intensive data model retraining required? No. We just might need incremental changes to our present model. It might not need a complete or drastic change in the model unless a concept shift occurs much later. Batch was an online prediction. Is prediction required immediately for new data? Yes. Every time I click on a button to create a new task, I need the prediction to come up. How immediate should data drift concept or concept to be handled? We would have a slow monitoring system, constantly monitoring metrics, and then decide on that. So the conclusion is we make a cloud-based but hybrid-based as well. So more on cloud-facing and a little bit of hybrid features of edge model for high security data clearance teams, with offline learning and online prediction based model with also regular monitoring for this. So that would be our ML system design. Potential risks in production. One, model learns from biased or not representative historical data. So more backend tasks than front end. So training data skew is an issue for us. And data can also occur with time. Technological changes might change the input features to diverge from what the model has been trained. And the concept of the tax complexity changes over time, altering the relationship between the input and the actual duration. Bias in the prediction system consistently might underestimate or overestimate for certain teams. For teams that have been hyper efficient, it might start expecting more from the team by giving lower estimate times. And the regulatory scrutiny may be a constant predictions influencing work allocation, could raise fairness, transparency, or labor concerns as well. Sensitive data used for modeling could expose individual developed patterns if it's not anonymized. And that can also lead to privacy concern and a potential pushback from the organization regarding the stability of the job for the developer. And the lack of interpretability, if the predictions aren't explainable, the trust and adoption would affect the outcome metrics. So with this, I think we come to the conclusion of our project, and I hope I have clarified most of the doubts that have been there. And thank you for your patience. And we